Hello again. So today we're going to put some algebra into these special angle pairs. So these are our first three examples. And what we're going to do is actually name the angle, the pair of angles first, because that'll tell us how to set up our equation. So in this first one, you'll notice that, and let me use a highlighter, you'll notice that the angles form a Z. So whenever you have angles that are going to form that Z or a backward Z, those are called alternate interior angles. And we can abbreviate with alt interior is int and then the angle symbol. So alternate interior angles. Okay, and what we know about alternate interior angles is that they are congruent to each other. So 60 degrees is the same as 8x minus 4. So the equation we can set up here is 8x minus 4 equals 60. Okay, once we have that, we can add 4 to both sides. And we get 8x is equal to 64. And then divide by 8. And there we get x equals 8. Last thing you should always do, we've talked about this every time, is you want to label the angle or plug this x back into the picture. Okay, so 60 degrees is still 60 degrees. You plug in the 8 here, and you get 8 times 8 is 64, minus the 4 is also 60 degrees. But again, that's a good way to check to make sure that you've done this correctly. Number 2. Number 2, a lot of times kids have a hard time identifying what kind of angles these are. So we have the parallel lines, and then we have 2 intersection points. Okay, and these angles are both in the upper left corner of the intersection. So those are going to be in corresponding positions. So these are going to be corresponding. So those are corresponding angles. And we know that corresponding angles are also congruent. So if they are congruent, that means that 11x minus 2 is equal to 75. Okay, solving, add 2 to both sides. 11x equals 77. Divide by 11 and x equals 7. And again, last step, you're going to plug that into the picture to make sure that is true. So 7 times 11 is 77, minus the 2 again is 75 degrees. So that checks out. Third one. So the third one, when you have those parallels, let me get a highlighter again. You have these parallels, and then this time the angles are between the parallels or interior, and they're both on the same side of the transversal. But the way you can identify that, because sometimes the picture is not super clear, is if the angles form the end of a parallelogram or the end of a rectangle or quadrilateral, but it looks like the end of a parallelogram, those angles are same side interior angles. Okay, and what we know about same side, and we're going to abbreviate this as well, same side interior angles. What we know about same side interior angles are that they are supplementary. So what that means is these are going to add up to 180. So 20, that's a 20, x plus 5 plus 24x minus 1 is equal to 180. Supplementary. Combine like terms. So 20x and 24x is 44x. 5 minus the 1 is 4 equals 180. Subtract the 4. And we have 44x equals 176. Divide by 44, you can use a calculator, but that is going to be 4. And then, of course, we are going to plug into the picture. So 20 times 4 is 80, plus the 5 is 85. Now remember, these should be supplementary. So this guy should be 95 if we did that correctly. So now we're going to plug in the 4 here. 24 times 4 is 96. And you can use a calculator. Minus the 1 is 95. Okay, and those two are going to add up to 180. So therefore, those also check out. So this is the process you want to use for all of these practice problems here. So I'm going to give you a few hints on the first three, and then the back side you'll do during class. Well, on your own. Okay, so number one, you're going to name the angle relationship. So are they alternate interior, alternate exterior, corresponding, same side interior, vertical angles, linear pair? There's so many choices. Find the variables and then label the angles again. So in this picture, again, when you see the parallels and the angles form the end of a parallelogram like this, those are same side interior angles. So this number one here is going to be just like example 3, just like this. Okay, on number 2, this one's a little bit harder to see. So if we extend these lines out just a little bit, makes it a little easier to see. But this angle here and this angle here are both in the upper right corner of the intersection. So if they're in the upper right corner, those are corresponding angles. So number 2 is going to be very similar to what we did for number 2 in our warm-up. Okay, number 3. So this one makes it a little more difficult. You got to think a little bit more for this. So we have a bunch of angles named. We only have this one set of parallels. Okay, these other ones are not parallel. But let's just look at the x's to start with. So if you look at the x's, we have an angle here, that is x plus 20, and then we have an angle right next door, which is x plus 10. So these two are from chapter 1, and we worked on these quite a bit, but when they are next to each other, adjacent, and they form a line, so remember, those are called a linear pair. And as a reminder, a linear pair will add up and equal 180. Okay, for the y's. So these are a little more difficult. So we are given this angle here is y minus 40. And then the y is over here. And that is not a special pair of angles. So what you have to actually do is think about how can I label another angle that I do know. So for example, I know that this angle here is the same as this angle down here. Those would be corresponding angles and they're going to be congruent or equal. So what I'm going to do is take this y and label it in this angle as well. So now I have this y minus 40 and this y, which are adjacent and form a line. So now those are also going to be a linear pair. And as we wrote just above here, a linear pair adds up to 180. So now these two angles will add up to 180. So that's a little trick you can do, is to relabel a variable into a different angle to help yourself set up an equation. Okay, so you'll try all 3 of those with the setup and solving, and always label the angle measures. On the back side, so you're going to use that same logic that we just talked about to find the rest of these variables here. Label all the angle measures. Number 5 and number 6 are pretty difficult, but I want you to give them a try. And I will see you next time.